All right, let's talk about manufacturing. At the end of the day, success really comes down to one thing: keeping your machines running. Today, we're going to pull back the curtain on two of the most important numbers that tell you exactly how well you're doing that: MTBF and MTTR. Let's dive in.
You know, there's one word that can send shivers down the spine of any plant manager: breakdown. It's so much more than just a busted part. It's a sudden, expensive, full stop to your entire operation. And that really gets us to the heart of the matter, the biggest challenge in production. What happens when a machine fails? And more importantly, how do you even begin to manage that chaos? Well, the impact is instant, and it creates this massive ripple effect. The moment a machine stops, your production plummets. That means your costs shoot up, and probably worst of all, deliveries get pushed back, which can really hurt your reputation with customers.
So how in the world do you fix a problem that big? Well, you can't fix what you can't measure, and that's where our two heroes for today come in. Think of MTBF and MTTR as the vital signs for your factory's health. They are the tools you need to diagnose what's wrong and figure out how to make it better.
Okay, so let's jump into our first metric, which I like to call the reliability meter. This is all about how long you can actually count on your equipment to just do its job. No drama, no interruptions.
So the official term is MTBF, which stands for mean time between failures. It's pretty much what it sounds like: the average amount of time a machine works perfectly fine from the end of one breakdown to the beginning of the very next one.
But let's just cut through the jargon. All MTBF is really asking is this: on average, how long is this machine going to run smoothly before it gives you a headache? It is a pure, simple measure of how reliable that machine is. So for our little example here, let's say the answer is a nice round 200 hours. Okay, but what does that number actually tell us? And how did we even get it in the first place?
Well, the calculation is actually beautifully simple. You just take the total time the machine was up and running, in our case, 1,000 hours, and you divide it by the number of times it failed, which was 5. Boom, 200 hours between failures. Now here's the crucial thing to remember. For MTBF, a higher number is always better. More time between breakdowns means you've got a more reliable machine, simple as that.
Okay, on to our second key number, the speed meter. This one isn't about preventing the failure. It's all about how fast you can bounce back after it happens.
This is MTTR, or mean time to repair. It measures the average time it takes from the exact moment a machine goes down to the moment it's fixed, tested, and ready to start producing again.
Or, to put it even more simply, MTTR just answers one question: when something breaks, how fast can my team get it fixed? This is a direct reflection of how efficient and prepared your maintenance crew is.
So using our same factory scenario, let's say the MTTR is 10 hours. That's the average time it's taking the crew to get that machine back online every time it goes down. And hey, look at that, the math is just as easy. You take the total time spent actively repairing the machine, say 50 hours, and divide it by those same 5 failures. That gives us 10 hours per repair. Now here's the big plot twist. With MTTR, you want this number to be as low as possible. The faster the repair, the less time you're losing. So, how do these two ideas hit together? We have one number we want to be super high and another we want to be super low. You might think they're fighting each other, but they're not. They actually combine to give us the holy grail of manufacturing: availability.
This table just lays out the difference perfectly. MTBF is focused on reliability. Its entire job is to reduce how often breakdowns happen. Your goal? Make that number huge. MTTR is focused on maintainability. Its job is to slash the downtime when a breakdown does occur. Your goal there? Make that number tiny. Two totally different jobs, but they're working for the same team. And this is where they finally come together. The formula for machine availability is simply your MTBF divided by your MTBF plus your MTTR. This tells you, as a percentage, how often that machine is ready and waiting to do its job.
And check it out, this visualizes our result perfectly. With an MTBF of 200 hours and an MTTR of 10, our machine has an availability of 95.2%. That means for over 95% of the time, that machine is ready to make you money, with less than 5% of its time lost to being broken or fixed. Not bad. So this all leads to a really interesting question, doesn't it? What's actually more important? Should a factory pour all its money into getting super reliable machines that almost never break? Or should it focus on building a lightning-fast repair team that can fix anything in minutes?
Let's make this totally practical. Imagine you're the one with the checkbook, and you have to choose between two different machines. Which one is the better buy for your factory?
Okay, here are your options. Machine A is an absolute workhorse. It runs for 300 hours between failures. But when it does break, it's a beast to fix, taking 20 hours. On the other hand, you have Machine B. It's less reliable, it breaks down every 150 hours, but your team has it figured out and they can get it running again in just 5 hours.
So, what's the verdict? Who wins? Well, the answer is, it totally depends on your strategy. If you're running something like a chemical plant, where any shutdown is an absolute catastrophe that costs millions, Machine A's reliability is king, no question. But if you're in an assembly line where short stops are annoying but manageable, the speedy recovery of Machine B might actually be way more valuable.
And that really brings everything full circle. MTBF and MTTR, they're not just some numbers on a spreadsheet. They're a powerful lens you can use to really understand and improve how things work. So the real question I want to leave you with is this: how reliable and how repairable are the systems that you depend on every day?